Okay, from the last project that we did, we had functions. I usually would like to keep each project separate from the previous one, but since I just recorded the previous project, let's create our new project. Okay, we worked with arrays but had not explained how they work. Okay, I'm not sure what's going on here. Let me actually close the project and create it once again. It's not supposed to be doing that. I've just created a project and it did not give me the same error message. Let's just create a sample one. Okay, I don't know what happened with that one. Okay, now we have a funny named project. Anyway, let's get to the basics. I think for this one I might need to have a notepad where I just explain a few things. Okay, like we said, we want to work with arrays. Okay, and our array, as we saw in the previous program, we actually had not quite explained how arrays work, but let's explain an array in its simplest form. We are simply saying we have a data type. From our data type, we've also got the name, and from the name we've got the size. Okay, so what this then means, we can actually substitute each element and have the content that we want. We could either have a character data type, and then the name can be anything really. It can be num, and then the size can also be anything. It can be an empty, or it can be an array that contains some value, okay, which then becomes the size. So we can either have this or that. That then makes our array. Okay. At the same time, we can also have it as an integer. We can also have the name. We can also have the size being exactly the same, or a size that we'll put within the brackets. So this is what we then mean with our arrays. However, what this then means now is the moment we've got our array in this particular regard, we can now be able to put specific changes that our normal variable doesn't have. So for example, we've got what is called an array index. Okay, our array index simply means we start from a specific point. Okay, and the point that we start from is from the beginning to the end. Okay, so where is our starting point? Usually in any array, our starting point is position 0, and our end point is usually n minus 1, like that. So what this then means is, if we've got an array, for example, we've got 4, that was our array. So we start at 0 to 3. Okay, how do we then match 0 to 3? We're then saying 0 to 3 is the number of positions that we've got in our array. And then to get to our 3, how did we get to our 3? To get to our 3, we simply said n minus 1, which in other words is 4 minus 1, which gives us 3. Okay, so that's how the whole logic pretty much works, or that's how we actually start with our array. Okay, let's have some examples. It's usually easier to work with an example and we build from there. So we want an integer array. where our integer array can be b, and then the size of that array is 4, like we've got, and then we put an equal sign, and our equal sign will then have curly brackets, and we have the following numbers. So we want 2, 4, 6, and 8, okay, which then become our numbers. We put a semicolon. We can do the same again for the next element, which can be NAM, open and close brackets. We put 4, we then put is equal to curly brackets, we put our semicolon. So for our integers, we simply can put the following, which is 2, 4, 6, and 8, separating them with our comma. For our characters, however, we need to put single quotes for each character, each character would then be within those codes. So for example, the text that we can put can be H, E, R, E, like that, which then means we've got our content that we want to work with. So to simply view any of these values, we can simply put a printf, we open and we close brackets, and then we state the following, whereby we can say b in brackets 2 is equal to %d. We put a new line, put a comma, and then say b in brackets 2. We do the same as well for our character, where we say NAM. In this particular instance, we now want 1. We change that to NAM, and then in brackets we now want 1, and then we want to put %C, since we have changed the type of data that we're working with, or the data type that we're working with. So if we run it, we should now be able to see the following. B at position 2 gives us 6, and NAM1 at position 1 gives us E. Okay, so in other words, we're then saying this is how we work with our arrays. So I decided to create a program that will show us how to actually put our values within the array, or help us to observe how each element works within a particular aspect of the array. So in this particular project, or in this particular program, here's what we are simply saying. We are simply saying each array, okay, is created in a single dimension, which then means when we say b in brackets 4, we're actually putting 4 positions in a single object. In those 4 positions, we can now be able to reference any of the positions to give a result that we think we might want to display. When we are then saying printf, we open and we close brackets, we are then referencing a position. So if it's b in brackets 0, we expect to find the value that is at that position, which is 2, and that's pretty much how our arrays work. The same applies for our character arrays. Okay, but like I said, this is the work of our arrays in a single dimension, or rather in a single platform that we can be able to then add whatever it is that we want to add. Okay, So what then happens if we want to display the entire name, for example, printing? So we can say NAM is equal to %s, we open brackets, NAM, like that. Okay, so we want to get into a new project that I've just actually worked with, and we want to do the following. We want to be able to create a two-dimensional array where with our dimensions now we can actually expand them from what we originally had. Okay, so let's say we want to have an integer, and our integer should be NUMS, which stands for numbers, and NUMS has the following content. Okay, it's got 3, it's got 4, and this then means here's how our project would run, or here is how our project is supposed to run. We're supposed to have three columns and 4 rows. Okay, so this then means would need, for the rows, we need 4 if I'm not mistaken, 1, 2, 3, 4, 5. I think that's too many. 1, 2, 3, 4. We need 4, like that. So each of these will then contain our numbers, which can be the following: 6, 1, 9, 8, 12, 32, 8, 1, 13, 9, 6, 2, like that. So in other words, we've created our sets where each set has got 3 elements and we've got 4 sets. Okay, if our logic is right, we should be able to pick specific elements based on this. Okay, so we can then be able to say, for example, the elements we want to pick are as follows. If you remember, we mentioned that when we're working with the first element, we said each element would be n minus 1. Okay, so we can do n minus 1 for the first row, which would be 3 minus 1, which gives us 2. And we do the same for the next one, which was 4. So it would be 4 minus 1, which gives us 3. Okay, so in that particular order now, we are now saying at any given point in time, we've got specific addresses. How are we getting these addresses? We are then saying if we've got two options, at a certain point we should have 0 and 1. We should also have, at a specific point, we should also have 1 and 1. However, the highest would be maybe 3 and 2. That should be the highest. Okay. So given that these are just basic explanations, it'll be easier when we're working with some code or when we're doing some code. So let's say we want to work with something at position 0, 0. Okay, we then say the following: %d, we put a new line, put a comma, and then we say nums. We want to get at position 0 and 0, like that. So if we run it, we'll be able to get 6. Okay, 6 becomes our value. Okay, we can also do the same for all the other values. Okay, so let me just maybe copy and paste this maybe 4 times. With the 4 times, we can switch the value so that we see what each element gives us. So for example, here I can put 1, 0. I change 1, 0. There I can put 1, 2. I also change there and I put 1, 2. I also change there and I put 3, 2. I also change that part 3 and then 2. Okay. So what this then means, if we've got a value at the given position, we'll be able to see the result of whatever has been put there. But if we don't have a result at that particular position, we're just supposed to get an error or to get an empty value. So if we run it, we'll then get the following. Okay, so 32 exists, which is fine. But in this particular case, we've got 3 and 2, which we had agreed that 3 and 2 exists. But 3 and 2 does not give us what we are hoping to get. Why? Because it's giving us that value. So the moment it gives us that value, it then means at that particular location, we don't have anything that we can work with. So what this then means now is you need to also understand how your arrays or how your elements pretty much work. Okay, so let's maybe try and do it logically without actually having this content there. We are simply saying the following. When we've got our code like that, I think let me just copy it and paste it to my notepad and explain how each element works. Okay, we'll paste our content as follows. What we are saying in this particular context, we are simply saying we want something that looks like this. We want to have our, okay, my mistake. We want to have our content like this, where each element is actually stored in a given order, where we are saying, we mentioned there being the following. So this becomes position 0, this becomes position 1, this becomes position 2. Okay, when we come here, the next thing is the next position is position 0, this becomes position 1, this becomes position 2, this becomes position 3, like that. So what it then means now is whatever it is that we are referencing, we're actually working with these positions to get specific values. So each value that we're working with, we can then be able to actually get it from these positions. And that then means we're having our dimension. So 0, 0 gives us 6. And then 1 and 3 also gives us 6. 1 and 0 gives us 8. 2 and 1 gives us 1. 1 and 0 also gives us 1. So this is how we're actually referencing our positions. So for example, this is 0 and 1. 0 and 1, let's see with our output. We have 1 and 0, which gave us 6. So if you come to this, 1 and 0, which gave us 6, which is there. Okay, let's see the next one. The next one was no. I made a mistake. 1 and 0 gave us 8. What is this one? This one we did not change it properly. This one should be 1. Oh, it actually just copied exactly as it was. So this one is a problem. Okay, so that's fine. So we're saying for the 8 it's 1 and 0. What does that show us? Let's see here. We've got 1 and 0, which then means we actually start with the higher number, which is the 4. So we have our 1 position there and our 0 there, which gave us 8. So that's how we got to 8. We've also got our 1 and 2, which gave us 32. So we are on this particular point and that particular point, which also gave us a value that we want to work with. Then the next one was we actually wanted to work with 3 and 2, which gave us that. So with 3 and position 2, we're actually supposed to get a figure. I'm not sure why we didn't get a figure there. We were actually supposed to get a figure based on this logic, because we were saying we're looking at that. Okay, let's just maybe change and say 2 here, 3 there. Okay, let's run it. We're getting 0. Why are we getting 0? Okay, because 3 doesn't exist here. Okay, so what we had originally should actually give us an answer, and I think we can actually work with that to get to see if we've got problems or elements that are actually giving us this random number, because this is actually a random number. Maybe you guys can look into it and then tell me where would have actually gotten it wrong. But I think for this particular lesson, I can end here.